Okay, today we're doing Algebra 2, Chapter 4, Section 1. So we're going to talk about finding inverses of functions. We'll talk more about what the inverse graph actually looks like in the next section, but today we're just going to talk about how to find them. So these are the steps for finding inverse. The first step is you're going to rewrite the function using y instead of f of x. So I'm just going to rewrite it. After that, we're going to switch the x and the y in the equation. So the y is going to become x, and the x is going to become y. And then we're going to solve for y. So now we got to get this y all by itself. So I'm going to add 4 to both sides. I have x plus 4 equals 3y. And now I have to divide both sides by 3. So my final answer then is y equals x plus 4 over 3. And from there, I can find the domain and range of this. So you can look at graphing it. You can see that it's just got an x here, so it's linear, and we're going to start talking more about that in domains and ranges of linear functions here soon. Or you can plug some values in. But the domain and the range are all real numbers for this graph. All right, so let's go ahead and find a couple more. We're going to determine if it is a function, meaning does it pass the vertical line test, and then we're going to state the domain and range. All right, so this first one right here, first thing I'm going to do, change that to a y. And then I'm going to go ahead and swap my x and y. And you take the square root of both sides. Now I have the square root of x equals y minus 3. And I'm going to add 3 to both sides. So now I'm going to get y equals, and I always change this around at the end, so my y is at the beginning. So y equals the square root of x plus 3. And one thing I didn't tell you is that function notation for an inverse is f to the negative 1 of x. Okay, so at the end, we can change that back if we want to. And sometimes you'll see that notation. That means the inverse function. Okay. So now it says determine if this is a function. So this graph is going to look something like this, okay, at 3. So is this a function? Does it pass the vertical line test? Yes, it does. So yes, it is a function. Okay. And then we need to find the domain and range. So our domain is going to start at 0 and include it and go all the way to positive infinity. And our range is going to start at 3 and go to positive infinity. And once again, if you graph this on your calculator, you can see that also. So let's go ahead and do that to remind you how to do that. So I'm just going to plug this in. So my y1, I'm going to put square root of x. Make sure you close that parenthesis. And then I'm going to put that plus 3. Okay. If you don't have a parenthesis here, if you have a newer one, you might just need to push the over key right here to get out from under that square root. Okay, so now we're going to go on ahead and graph this. And you can see from the graph, okay, or remember you can hit second graph and you can see a table. And the table will show you your domain starts at 0 and goes up and up and up. And your range starts at 3, your y value, and goes up and up and up. Okay. All right. So let's go on ahead and do this next one here. So I'm just going to say y equals 2x, 3x, 2x to the third minus 1. So now I'm going to add 1 to both sides. Oh, no, what did I forget to do? I didn't change my x and my y here. So y equals 2y to the third minus 1. Now I'm going to solve. So add 1 to both sides. I get x plus 1 equals 2y to the third. Next, I have to divide both sides by 2. So I get x plus 1 over 2 equals y to the third. And now I need to take the cubed root of both sides. Okay. So I'm taking the cubed root of both sides. And I just realized something, and I'll show you in just a second what I just realized. So the cube root of both sides. And when you take the cube root, you don't have to make it a plus or a minus. So now I'm going to have y equals cubed root of x plus 1 over 2. Okay, so let's go ahead and take a look at what that looks like. And then I'll come back and show you what I forgot to do here, which some of you may have noticed already. So this is going to be the cubed root. So it's going to be x plus 1 divided by 2. And that's going to be cubed, which is to the 1/3 power. Okay. And I can go ahead and graph that. What to do? Okay. And you see what it looks like there. So it goes kind of like this and kind of like that. Okay. So that one right there is a function. Okay. So yes, it is a function. The domain is from -infinity to +infinity, and the range is from -infinity to +infinity. Okay. So we'll talk about this in the next section too, but one way to determine if the inverse is a function, okay, is it 1-to-1? In other words, does it cross both the horizontal and the vertical line test? And remember that even though this looks like it's straight, it's really not. It's really going up and up and up. Okay. So make sure that you notice that. Okay. So this one is a function. Okay. All right, so this one right here, let's take a look at this real quick. So x minus 3 squared. Okay, that is actually a parabola located here. Okay. So when I do something to this graph, I find the inverse. It has to look just like this, but we'll talk, like I said, we'll talk about it a little bit later about how it's how it changes. So this one right here, I forgot when I took this square root right here, I forgot to take the plus and the minus. Okay, so the plus and the minus, which would make it also go like that. Okay, so no, this one now is not a function. Okay, our domain is the same, but now what is our range? Okay, our range now is going to be -infinity to infinity. Okay, so you know, that is one of the biggest mistakes I see on tests. Okay, so remember that that mistake right there can cause a lot of issues. Okay, so make sure you remember to do that. All right, let's go on ahead and do the. All right, so the next one says to determine whether two functions are inverses of each other, take the composition of each pair. So remember that the composition is where you find f of g of x and g of f of x. Okay? So we're going to plug this function into x in this one, and then we're going to do the other way around and plug this function into x in that one. If both of those equal x, and both of them have to equal x, then we know they're inverses of each other. Okay? So let's take a look at number A, letter A, whatever this is. All right, so f of g of x. Okay. So my function f is 2, and then I have my x, so I'm just going to put parentheses right there, plus 4. Now I'm going to take my g function and put it in here where my x was. All right, now let's go on ahead and work through this. So we're going to distribute. So 2 times 1/2 is 1x. 2 times -4 is -8, okay, plus 4. So we're going to have 1x minus 4. Okay, so that one right there is not x. So already I can tell that these are not going to be inverses. Okay, let's go on ahead and take a look though when we do the other way around and see what we get. Okay, so now I'm going to do my g function. So my g function is 1/2 and then x. I'm going to leave a parenthesis, minus 4, and this is 2x plus 4. Okay, so I'm going to distribute 1/2 to 2x and 1/2 to 4, and I get 1x plus 2 minus 4, which equals 1x minus 2. Okay, so neither of those equaled x. Okay, so this is not inverses. Okay, and when I say tell me why or why not, what I'm expecting is the work here. Okay, you don't actually have to say, you know, what happens. You need to show me that they both equal X or show me that they both don't equal X. Okay. All right, let's take a look at this next one. So the next one says 4X is greater than or equal to 0. Okay, and the reason for that is because this has to be greater than or equal to 0. If it's a negative number, it makes it imaginary. Okay, so that's why we're using that domain. We're going to find f of g of x. Okay, so we have 1/4 my x value, okay, squared. Okay, my x value I'm going to plug in here is 2 times the square root of x. And remember that when you're squaring this, you have to square both pieces. Okay, so that's going to give us 1/4 times 2 squared, which is 4, and the square root of x squared, which is x. Okay. So now 1/4 times 4x is just x. Okay, well, that one worked, but I still can't say they're inverses yet. Now I have to prove that g of f of x also equals x. So now I'm going to say 2 times the square root of x. Well, what is that? That's 1/4 x squared. Okay. So now I'm going to go on ahead and do these. Perfect. So that's going to be the square root of, so that's 2 times the square root of 1/4 times x, because x squared, the square root of x squared is x. Okay, well, 2 times 1/4 is 2/4, which is 1/2. So that's going to give me 1/2 x. So you notice those both did not equal x. Okay, so because they did not both equal x, then we know that it's not inverses. Okay, so let's take a look at this next one and see what we get. Okay, so f of g of x equals 2/3 times x plus 6. Okay, and my x value is going to be 3/2x minus 9. Okay, so now I'm going to go ahead and distribute 2/3 times 3/2 x is just x. And 2/3 times -9, 2 times -9 is -18. Divided by 3 is -6. And then I have that plus 6 at the end. So that equals x. Okay, but now we need to check our g of f of x, because remember, both of them have to equal x. So I have 3/2 my x minus 9. And my x value now is my f function. So that's going to be 2/3x plus 6. So 3/2 times 2/3 x is just x. 3 times 6 is 18, divided by 2 is positive 9 minus 9. And my answer is x. So yes, these are inverses. Okay, this one was not. All right, and now let's look at our last problem for today. You guys are going to have some practice doing this, and I'm going to give you a little bit of a tip here in just a minute, but let's finish this last one. So we have to find f of g of x first. So I have my x value squared plus 5, and my x value is the square root of x minus 5. Okay, so now I'm going to have to go on ahead and square that. Well, this right here is a binomial. So the square root of x minus 5 times the square root of x minus 5. Square root of x times square root of x is x, minus 5 square roots of x minus 5 square roots of x plus 25. And then I'm going to go ahead and combine my like terms, and I get x minus 10 square roots of x plus 25, and then I get plus 5. So now I'm going to have x minus 10 square roots of x plus 30. Yeah. So right now, just looking at this, it does not look like they are going to equal x, right? Because I can't combine like terms anymore with that. So let's go on ahead and look at our g of f of x. Okay. So we're going to do the square root of x, which is x squared plus 5, And we're gonna do -5. Well, the square root of x squared is x. Okay, but then we're gonna have plus the square root of 5 minus 5. Okay, well, those are never gonna cancel. Okay, so we're not gonna get x out of that. So if you start to work these problems and they start to look really nasty, okay, chances are they are not going to be x's, okay? So if they start to look really nasty, they're not going to be x's, they're not going to be inverses, okay? But try both of them, and if both of them get so nasty that you just can't work them, then it's not going to happen. Okay, so today you have an activity on that, and tomorrow we'll talk more about what the graphs of inverse functions looks like. Have a great day.